For decades, Pluto sat at the edge of our imagination, a lonely, icy world drifting on the outskirts of our solar system. Small, distant, and mysterious, it was long believed to be little more than a frozen rock, too far away to ever truly matter in the grand cosmic picture. But all of that changed the moment NASA's New Horizons spacecraft completed its historic flyby and sent back images that completely shattered our understanding of this distant dwarf planet. What those images revealed left scientists stunned, left the rest of us asking, what is Pluto really? When New Horizons finally reached Pluto in July 2015, after traveling more than 9 years and over 3 billion miles, scientists braced themselves for grainy images of a barren, featureless surface. Instead, what they got was a jaw-dropping landscape more dynamic, colorful, and complex than anyone dared to imagine. These weren't just ice plains and impact craters. They saw mountains taller than the Rockies, massive glaciers of nitrogen ice, and hints of an internal heat source that shouldn't exist in such a small, cold world. The first close-up image released stunned the world. A heart-shaped region, unofficially named Tombo Regio after Pluto's discoverer, stretched across the surface in bright, reflective ice. But this wasn't just a symbolic valentine from the cosmos. It was geological proof that Pluto was alive. Geologically speaking, the western lobe of the heart, now called Sputnik Planitia, is a vast plain of nitrogen ice, with no impact craters. Why is that significant? Because the lack of craters means the surface is young, possibly less than 10 million years old, which implies ongoing or recent geological activity in a world thought to be frozen solid for billions of years. That was an absolute shock. Even more surprising were the towering mountains rising up to 11,000 feet, made not of rock, but of solid water ice. On Pluto, water ice acts like bedrock. Because it's so cold, it's as hard as granite. These mountains hint at tectonic forces, internal heat, and perhaps even ancient cryovolcanoes, ice volcanoes that erupt slushy mixtures of water, ammonia, or methane instead of lava. Yes, Pluto might have volcanoes. Just let that sink in. But the mysteries didn't stop there. New Horizons captured images of strange pitted terrains and cellular patterns that suggested convection where warmer material rises and cooler material sinks. Scientists believe that Pluto's nitrogen glaciers may be churning very slowly, like a lava lamp, over timescales of millions of years. That's active geology. On Pluto, a place we once thought of as a dead ball of ice, the surprises weren't only on the surface. Pluto's thin, hazy atmosphere also turned out to be far more intricate than predicted. As New Horizons passed behind Pluto, it captured the sunlight filtering through layers of atmosphere, revealing up to 20 distinct layers of haze. These layers stretched over 100 miles above the surface and scatter sunlight in such a way that during Plutonian twilight, the dwarf planet is softly illuminated in blue skies on Pluto. And even though the atmosphere is mostly nitrogen with traces of methane, it raises questions about complex chemical reactions that may be occurring in the upper atmosphere, leading to the formation of organic molecules known as tholins, which give Pluto its reddish-brown hue. Even Pluto's moons got in on the action. Charon, Pluto's largest moon, wasn't just a boring gray rock. It showed canyons deeper than the Grand Canyon, mysterious dark poles, and evidence of internal activity. One hemisphere even appears to have split apart in the past, suggesting that Charon might have once had an internal ocean that froze and expanded. Suddenly, this wasn't just one strange world, it was a whole system of icy, dynamic bodies in deep space. What does all this mean? It means we've been underestimating the outer solar system for far too long. If Pluto, a tiny world in the Kuiperbelt, can have active geology, complex atmospheres, possible subsurface oceans, and seasonal cycles, what else is out there? Could similar processes be at work on other dwarf planets like Eris, Haumea, or Makemake? Could some of these distant worlds even harbor the basic ingredients for life? The New Horizons mission forced us to rethink what makes a planet alive. It's not just about size or proximity to the sun. It's about activity, change, complexity, and Pluto has all of those in spades. So, while Pluto may have been demoted from full planet status, it has more than earned a new kind of respect. It's not just some icy leftover from the early solar system. It's a vibrant, evolving world with secrets still waiting to be uncovered. And here's the best part. New Horizons only spent a few hours flying past Pluto. Imagine what we might learn if we go back with an orbiter or a lander. The possibilities are enormous. The questions Pluto raised about planetary formation, geologic activity, and even the potential for life in the coldest corners of our solar system are just beginning to be explored. So, no, Pluto is not what we expected. It's something far more fascinating. And if we have learned anything from this tiny world at the edge of the sun's reach, it's that the universe is still full of sometimes the most extraordinary places are the ones we almost overlooked. Just when scientists thought they'd absorbed the full shock of Pluto's incredible complexity, the analysis of New Horizons data began to reveal something even more mind-blowing. Pluto might be hiding an ocean beneath its frozen crust. Yes, an ocean. Liquid water, possibly still sloshing beneath layers of rock-hard ice in a world that sits almost 4 billion miles from the sun. And the implications of that discovery are as chilling as they are exciting. At first glance, the idea of liquid water on Pluto sounds impossible. Surface temperatures average around -375 degrees Fahrenheit, cold enough to freeze even nitrogen and methane solid. But as researchers pored over the images and gravitational data, strange patterns began to emerge. For example, Sputnik Planitia, icy heart-shaped planets, positioned in such a way that it suggests the entire planet may have shifted its orientation. That only makes sense if there's a layer of something mobile inside Pluto, something that allows the crust to float and reorient. That something might be a global subsurface ocean of salty water, kept liquid not by sunlight, but by internal heat and antifreeze-like chemicals. This ocean, if it exists, collides just 100 to 150 kilometers beneath Pluto's surface. That's surprisingly close for something so alien and remote. It would be insulated by miles of rock-hard ice, and perhaps maintained by radioactive decay in the core. Just enough energy to keep that ocean from freezing solid over billions of years. The idea that Pluto might have an internal ocean isn't just cool it rewrites the rulebook for planetary habitability. It tells us that you don't need to be in the traditional habitable zone to have the ingredients for life. And that's where things start to get really interesting. If Pluto has an ocean, it could also have the chemical gradients and energy sources necessary for life, at least microbial life. Think about Europa or Enceladus, the ocean moons of Jupiter and Saturn. We've already found evidence of hydrothermal vents on those moons, environments on Earth that teem with life, even in total darkness. Could Pluto have something similar? Could we one day drill through its icy crust and find alien microbes adapted to a pitch-black, salty, ammonia-rich ocean? Of course, that's still speculation. But New Horizons gave us another clue that life, or at least the building blocks of life, might be present. Organic chemistry. The reddish-brown tint on Pluto's surface is caused by complex organic molecules that form when ultraviolet light interacts with methane. These molecules can combine into more complex structures over time, and they're thought to be a crucial step on the path to life. Pluto is literally coated in them, there in the atmosphere, on the surface, and likely raining down like snow. In short, Pluto is a frozen chemistry lab, mixing up the same kinds of compounds that may have sparked life on early Earth. Let's zoom out for a moment. All of this, the ocean, the geology, the chemistry, points to a simple truth. Pluto isn't just a curiosity. It's a window into the outer solar system. It's part of a vast, unexplored region called the Kuiperbelt, a disk of icy bodies stretching out beyond Neptune. For decades, we thought of the Kuiperbelt as a graveyard of leftovers from the solar system's formation. But Pluto showed us that it's more like a hidden treasure trove, and Pluto might just be the beginning. Imagine this. If one tiny world on the edge of the solar system can have such rich, complex features, what about its neighbors? Eris is about the same size and even farther out. Make and Haumea have unique shapes, fast rotations, and their own mysterious characteristics. Some of them even have atmospheres. We're just scratching the surface, and there are potentially thousands of similar bodies we haven't even discovered yet. The Kuiperbelt may turn out to be one of the most diverse and dynamic regions in our entire solar system. But here's the challenge. We've only had one flyby. New Horizons gave us a brief glimpse, a snapshot of a living world in motion. What we need next is a dedicated mission, an orbiter that can spend months or even years studying Pluto and its moons up close. We need better data, deeper scans, and the ability to watch changes in real time. We need to land on the surface, drill through the crust, and maybe touch the hidden ocean below. These are no longer science fiction ideas. They're the next logical step. The legacy of Pluto's discovery in 1930 has gone through dramatic turns, from mysterious Planet X to ninth planet to dwarf planet status, to now something much more. Pluto has become a symbol of how much we still have to learn, not just about the solar system, but about our assumptions. We assumed Pluto would be dead. It's not. We assumed it would be simple. It's anything but. And now, we're forced to confront the reality that life, chemistry, and complexity might exist in places we never thought possible. So when people ask, why explore Pluto? Why send spacecraft billions of miles to a frozen rock? The answer is clear. Because every time we look further, we find more wonder. Because Pluto surprised us and the universe is just getting started.